light it up, act down. What's the plan? Oh yeah, 2 plus 2, that's 4 all day. Subtraction slip, take it nice and slow. Minus 3 for 5, what you got? 2, let's go. Math is funky, can't you see? Prove it with the numbers, feel the beat. Oh yeah,
So we can do that. So first thing that we have to consider is that our coin, as you said, how many outcomes does a coin possess?
2.
So we know that a coin possesses 2 outcomes. And in this case, the spinner has got how many outcomes?
3.
So spinner has got 3 outcomes. Spinner has got 3 outcomes. These are outcomes. Now, normally we know that 2 times 3 will be 6. It will be a total of 6 outcomes. Now, we can make a tree diagram whereby we consider the coin toss. First, coin toss. So coin toss has got 2 branches. One being what? Another being what?
Tail and head.
Good. So one will be tail and the other one will be head. And we also know something else. What is the probability of being a tail?
0.5.
Excellent. It's half. In tree diagrams, I like to work with fractions, by the way, but okay, it's correct.
Yeah, it's because, Mister, it's because I did it with fractions, but then, I mean, I only said 0.5 because in this case you gave it in 0.5. It's a 0.3, 0.6,
Fully
0.1.
agree. Fully agree. I like that. I like that. So you just follow the logic. You are consistent. So it means that you're taking 0.5, which is okay also. Very good. 0.5. And therefore, when it comes to our spinner, it's got 3 branches, right?
Yeah.
So from each of the branches of the coin, the spinner also will have its own 3 branches. So this is coin toss, and then this is spinner. We can just say spins. So the first spin will give us, as we said, the colors will give us red, blue, green. The same thing will happen here, red, blue, and green. Now, let's write the probabilities. In fact, again, let's be consistent. Let's write red here, blue here, and green here. Red here, blue here, and green here for consistency's sake. So we can be saying the same thing in the same manner. It's easy to maintain some logic when we do that. Okay, so now let's go to the individual probability. So we said red was how much? Red was 0.3, right?
Yes.
0.3, that's red. 0.6 for blue, and 0.1. We assume that, you know, in the spinner, all the probabilities will add up to
1.
Good. They should be complementary like that. So now here you have 0.6, and here, of course, you'll have 0.1. Now, it fulfills what we said about the outcomes, right? How many outcomes do we have?
6.
6 outcomes. So the tree is well drawn. Now we want to know the probability, for example, the probability of tossing a tail and getting, let's just say red, right? So the secret here of tree diagrams is to remember the multiplication rule. So the probability of getting a tail, where can I write that? So let's say probability of a tail and a red will be the probability of the tail itself, which is 0.5, right?
Times 0.3.
Very good, times 0.3. So this is like 3 times 5, 15. It should give us 0.15, right? If you have a calculator, you might want to confirm that, 0.1.
It is, Mister.
Thank you. So the same thing will happen with the probability of tail and blue. So not the same value, but 0.5 times 0.6. I believe it should be 0.03.
Yeah.
0.03, 0.03. And then finally, in this side of the tail, the probability of getting a tail and a green, landing on green. So it's 0.5 multiplied by 0.1. So this is what? 0.05, right?
Yeah.
0.05. Now we do the same thing for the heads. What about getting a head, lending a head, and the color red? It will be 0.5 times 0.3. It happens to be equal to the first one, to a tail in a red, right?
Yes.
0.15. 0.15. And then again, probability of lending a head and blue, probability of a head and blue will give us 0.5 times 0.06. 0.6. So that's like what? 0.03. 0.03. Finally, probability of getting landing on a head and getting a green color, that's 0.5 times 0.1. Again, we get a 0.05. 0.05. There you go. Okay. So now you can be asked questions like, which is the most likely result? What would you say here?
The tail and the red and the head and the red.
Very good. So these tail and the head and the head and the red. This is the most likely result. Indeed. So you can answer various questions. Hannah is going to play one game of chess and one game of backgammon. The probability she wins the game, she will win the game is 0.6. Obviously, what is the probability that you will lose the game of chess? So we're starting with chess. So
0.4.
excellent. So you got it. So if one probability is 0.6, we know that obviously the win is zero. Okay, win is 0.6. We can write it here. 0.6. So the loss is 0.4 automatically. And then they say the probability you will win the game of backgammon is 0.7 again. The other one is
0.3.
very good. So you got this. So already there you have half of the information you need to solve the problem. And they ask you a question, complete the tree diagram, we've done it. Work out the probability that Hannah will win both games. So how will you do that?
Times it.
Win, probability of win, what is it?
You times it, so
Multiply.
0.6. Yeah,
0
sorry, multiply.
Times 0.7, right?
Yeah.
So it's 0.42, right?
Can I confirm, mister?
Yes, please. 0.6 times. I'm not also 0.6 times.
Yes, you're correct, mister. Yeah.
0.42. So that is it.
Fighting is the key. Say it loud. Math is funky. Fractions in the mix. Oh, don't you fear. Half of 8 is 4. Now the answer's clear. Oh yeah. Decimal side. They got that flow. 0.5 plus 1. Where we go? 1.5. Let's roll. Geometry's got angles, triangles, and more. Parallel lines keep it smooth on the floor.